And recording. Yes.
Good.
All right. Welcome to all those viewers in Brazil. My one viewer. Keep talking about that. There's one in Pakistan and one in Brazil. The rest are in the U.S. But the one person from Pakistan didn't like one video I did. So only thumbs down. But it was my bloopers video, and I think he actually wanted to learn something. It's just me talking smack. You guys laughing. Some of you laugh. All right, so here we're just solving radical expressions, radical equations. The difference between, again, an expression versus an equation. If we have an expression, there's just, it's 9x squared, and we don't have it equal to anything. An expression we can only simplify. The rules are slightly different for expressions versus equations, but today we are dealing with equations. This is an expression, then we get down to the equations. Same process. Except when we have an equation, we have to just remember we have to do the same to both sides. So I put these inverse operation review up here because I want you just to remember when you have 2x is equal to 10, it's 2 times x, right? So instead of 2 times x, what do we do to get rid of the 2? What's the opposite of multiplying? Divide. So I know that I just divide by both sides. If you divide by 2, if you multiply by 100, whatever, as long as you do it to both sides, you're okay. That allows me to cancel. X is 5. Okay. So inverse operations, I just want to bring that up. When you have multiplication to isolate the variable, you divide. The same thing goes on when you have something squared versus something square rooted. They're inverse operations. So if I look at this, right? If I have the square root of 9 and I square it, essentially what I'm doing is the square root of 9 times the square root of 9, right? What is the square root of 9? 3. What's 3 times 3? 9. You can see right here that, what happened? The square root of 9 squared, the square root and the square are inverse operations, so essentially they just cancel each other out. The answer is then whatever in that root. Okay. This is how we're going to get rid of the root. So we get something like, example 2, when we square both sides, we get rid of the root. See how that's going to make things easier? Much easier, right? Okay, so I really like this because it's very straightforward. The other thing we have to remember is, if we didn't know about imaginary numbers, what would my answer be for this? Unsolvable, undefined, doesn't answer doesn't exist, or actually it does. So undefined, because we have a negative under the root, we have to use our imaginary numbers to deal with this problem, our complex numbers. But when we're double checking our answer, if we get down here and we have, okay, x is equal to negative 2. When I double check it here, what happens when we have the square root of negative 2? It's undefined there, right? We can't have that. So we're not going to go into complex numbers using imaginary numbers. Here we're actually just thinking about real numbers only. And in this case, if x equaled negative 2, but when I plug it into the original, if it doesn't work, then we do have an extraneous solution. So I'd say x equal to negative 2. Well, actually, you'd have an extraneous solution. X equal to negative 2. So we can list it. But it's extraneous, so we know that it works as we solve it, but when we plug it into the original, if it doesn't work, it's an extraneous solution. Okay. So we have a situation like this, and I think we've talked about it enough. How am I going to solve this? Square root of x equal to 3. What should I do? Square both sides. So I go ahead and rewrite so I don't have to rewrite later. Square. Squaring a square root, just like negating out a value by doing the opposite operation. Here we can just negate out both the square and the square root. They cancel each other. X is equal to 9. Okay. Then what do I need to do? Remember, you always have to do this last step every single time. What do we have to do? We found out what x is. Now what do we do? Plug it in. See if it works. See if it balances. Seeing if what you have here also equals what's on the other side. 9. Square root of 9 is 3. 3 equals 3? Yes. So you might do that real quick. Over here, 9 is equal to 3. I'm seeing if that's true. 3 equals 3? Yes. So this would be no extraneous extraneous solutions. Okay. So remember, you have to have the answer including if it is extraneous or not. Okay. So far, so good, right? So far, so good. So far, so good. Okay, go ahead, and this is a review. We've already talked about it a little bit, so go to knockout number 1 on your own. I'll give you 20 seconds, and then check with your neighbor. Check with your neighbor. Okay, double check with your neighbor. I think we're all probably going to have the same thing. All right, let's look at this together. I'm going to do the first step and then ask somebody to help finish it up. Remember, anytime you have something squared, you can expand it to get a better idea of what's happening. 3 times root 2 squared is 3 times root 2 times 3 times root 2. You guys see that? You agree with that? That makes sense, right? Now simplifying it is, we expand it out, we contract it back. What's 3 times 3? 9. Those are gone. What's root 2 times root 2? Answer? 18. Okay. You see? Okay. So if you get confused, the reason I put this one up here is when we square a root with a number out in front, we have to also think that number out in front is going to be squared as well. Okay. Because the entire thing is squared, I just wrote it out. Expand it if you're confused. If you get there and you're not sure, you got to write expand it, and I think from there you'll be able to see. And then you won't have to expand it very much more, because you'll just see how it goes. Okay. So somebody help me out with the first step here. First step for number 2. I don't think this one is. This is just as straightforward. What should I do? Okay. What if you said, I feel like squaring both sides? Could you do that? Could you do that? You can do whatever you want. Sometimes you'll just be going in circles. Then you'll go a circle over here, then you go back, and then you'll go in a circle. So don't go in too many circles. But you absolutely could say, I'm going to take this whole root x minus 4, and I'm going to square it. You'd have to do FOIL. It'd be horrible, but you could do it. But don't be a masochist. You can do the easier way. All right? So I like this. Let's plus 4, plus 4. Root x is equal to 1. What's next? Square. So remember, the square and the square root cancel. 1 squared is 1. Let's plug that in. Do we end up with the same value? Let's see. 1 over here. Square root of 1? 1. Positive 1 minus 4. Negative 3. Yes. So this works, and there's no extraneous solution. It's easy. Okay, I'm actually going to skip example 1 for you to do. I'll just reiterate the same thing. It's very similar. It's add 5, add 5. Seeing that we may not need 2 exactly like this. Square. Okay, we have x equal to 49. Let's plug it in. Square root of 49 is 7. 7 minus 5? 2. Yes. So it's really no extraneous solutions because it doesn't, for one, it doesn't make the square root a negative inside, but it also combines to actually give me my answer. Okay, so no extraneous solutions has to do with both of those concepts. All right, let's look at example number 2, our last example. And I want you to carefully work on this on your own. Let's go ahead and solve it all the way out. Yeah. 2 minus x under. Yeah, you may need a hint for this. You need a hint. Huh. Oh, Jason, where'd you get that red pearl apple nugget? Oh, really? They have those in? It's an apple that's red in the middle, that one. Cafeteria's getting all fancy. Shopping at the Nugget or something. Or the co-op. I like it if I'm willing to use my whole paycheck. Or Whole Foods / whole paycheck. They put some asparagus, 2 spears of asparagus in water, so $5.99.
Asparagus flavored water.
That's a markup right there, huh? 20 cents of asparagus and water. What a racket. All right, what was the first step? For those that maybe haven't done the first step, what am I going to do first? I want to isolate my x's. This one is under the square root, so yes, Seth, I like that. Squaring both sides. What happens on the left side? This may be, you're maybe a little confused here, but remember, the square and the square root are going to do what to each other? Negate each other out. Gone. 2 minus x is equal to x squared. And then now you have to think about, what do you think automatically when you see an x squared? What's my favorite type of formula? It's a quadratic, right? It's a parabola. We set it up in standard form. Remember, that's the step. Anytime you see a squared, I want you to think about this. Set it up. Ax squared plus bx plus c. You're setting it up in this standard form. So to do so, I would say, let's add x. That's minus 2. Add x minus 2. Gone. 0 is equal to x squared plus x minus 2. And then that's where we're going to go to our 2 expressions and almost be done. Negative 2 and 1. Does anything do that? Yeah.
Negative 2 and negative 1.
2 and negative 1. Is negative 1 multiply to give you 1? We need them to multiply.
Oh, yeah.
So it's the opposite, right?
I switched.
Okay. So remember that the 2 last terms with FOIL, the 2 last terms, remember, multiply to give us that negative 2. That's why we're looking for 2 values that multiply to give us negative 2. Because those 2 values is what we're looking for. So, yeah, I like that it's 2, negative 1. X plus 2, x minus 1. And then these are the roots. These aren't restrictions. We're not with a ratio. We're not with a fraction. So I can just say, since they multiply to give me 0, either this is 0 or this is. X plus 2 is equal to 0. X minus 1 is equal to 0. Maybe you could see it right off. I'm just helping those who can't. All right, I just set both of them. What? Oh, that's something else. That's not part of it. You solve for x. Minus 2 minus 2, x is negative 2. Add 1, x is 1. So we have our 2 solutions here. And then let's just double check, does it work? Let's see. Let's put in negative 2 up here. And it's not with all the squared, it's just back to the original. 2 minus x equal to x. So I do so. Negative 2, if I have 2 minus negative 2, that's 4. The square root of 4 is 2. So maybe for this one I should actually write it in. 2 minus negative 2 is equal to negative 2, question mark. This ends up being 4 is equal to negative 2, question mark. 2 is equal to negative 2? No. Not. So, right? And now double checking. Negative 2 is not a solution. Or do we just label it extraneous solution? What do you think? Ahoy. This is also true. So we can have it's true. The square root of 4. What times what gives you 4? Negative 2 times negative 2. positive 2 times positive 2. So actually, in this case, yeah, this actually does work out. We didn't have any negatives under the root, so we're okay. And so we can say negative 2 is a solution, because we have to remember that the square root of anything is plus or minus. Okay, so that's something that I hope sometimes when I make a minor mistake, it helps you guys not make that mistake. So I'm just giving you an example. All right, we plug in 1. What is 2 minus 1? 1. Square root of 1. Does that equal 1? Yeah. So we have this. We have no extraneous solutions. And we're done. Okay. Now, if you ended up with something that didn't match, so for instance, do we have one that didn't match? I'll put one up later, or next time that doesn't match. But if we plugged in a value and we had, here we had, negative 5 worked out negative 5 is equal to 4. If that doesn't work, then we're going to call that an extraneous solution. The actual solution would be what does work. Okay, so that's how we're going to approach that. Any questions? It's pretty straightforward, right? Thumbs up, sideways down for this. All right, that's mostly thumbs up. That's good. That's good. All right. We need an outro. Have we even recorded ever in this class?
No.
Once? Did we do something fun then? No. We didn't do anything fun at all. All right, does anybody have any shout-outs? Is it, wait a minute. Is it anybody's birthday? Don't say if it is. I'm going to surprise you. Nah, it's no one in here. Is it anybody's family member, mom, dad's birthday?
It's game day today.
It's what? Your uncle? Uncle who?
My Uncle Tom.
Uncle Tom?
Yeah.
All right, happy birthday, Uncle Tom. You got to subscribe now. So next year you can get another happy birthday. And?
It's game day today.
It's game day. Who are you playing?
Playing Casa Roble.
Casa Robles? Where are they from? That's
Somewhere out I want to say I don't even know. But they're
Oh, I'm thinking Paso Robles. That's not the same thing. Okay.
Casa.
Okay. And Malik, how do you feel about him hitting your head with that pencil like that?
Domestic
Psycho violence needs to stop. All right, so how about we do, let's see, what's something that's been coming up? All right, I'm going to start to make this viral. My niece made something up over Thanksgiving. I don't know if I've said in this class, but we had some green bean casserole with bacon on it. Bacon. So when something's cool, when something is like, it's good, it's, oh man, that's bacon. Because like when you put something in the oven, when something's getting hot, it's bacon. Bacon you eat, it's crunchy, it's good. So when something's good, bacon.
Oh yeah, bacon.
I think it's viral. I think that could be something.
That could be something.
There's stupid things out there. I think bacon could be one of the stupid things.
You might stroke the jackpot.
Bacon. All right, how about math is bacon on 3? 1, 2, 3.
Math is bacon.
Bacon.